Okay, guys, so today, this week, we're going to be going over 7.4b and 7.4d. Okay, and I've put a copy of these notes in Google Classroom for you so you can use them. Today, we're just going to be doing the notes. Okay, so 7.4b is over unit rates and 7.4d is over ratios, rates, and percent. So it's all rates. We're still doing some sort of rate like we were last week, okay? So this first one, a rate compares two different units. So miles to hours, gallons to liters, feet to miles, things like that, okay? We use a proportion. We use a proportion to compare two different units. Okay, so on these, we've been doing proportions for a while, guys. On these, we want to make sure we set up the proportion and then cross multiply and divide. Okay, so we're going to set up the proportion like we normally do with the equal sign in the middle. Okay, and then whatever your unit 1 is on top and unit 2 on bottom, whatever we're measuring in. Okay, the ratio of boys to girls. So it says the ratio of boys to girls. So when I set up my proportion, I want boys and I want girls. Okay, because that's what our ratio is comparing. In a 7th grade class is 5-3. So it said boys first, so this 5 belongs with the boys, and then girls would have the 3. Okay, so I'm going to put 5 boys to 3 girls. There are 15 boys in the class. So if that says 15 boys, I'm going to put 15 where the boys is, which means I'm trying to figure out what the girls are. What is the total number of students in the 7th grade class? Okay, so this proportion is going to help us figure out how many girls there are. And then to find the total, that means I need to add boys plus girls. Okay, so let's do that. 3 times 15. So we're going to do 3 times 15. 3 times 15 is 45. Okay. And then we're going to divide by my leftover number by 5. So 45 divided by 5. Okay, and 5 goes into 45 9 times. Okay, and that's my amount of girls. Okay, so I have 9 girls. I want the total, so I'm going to add the boys onto this. 15 plus 9. So 9 girls plus 15 boys. 9 plus 5 is 14. That's 24. So there's 24 total. And that's how we solve the ratios. Okay, moving on. A blank is a ratio that compares two quantities measured in different units. So this is a rate. A rate is a ratio that compares two quantities measured in different units. Oh, sorry, guys. I knew I did something wrong. This right here, this first word should be ratio. A ratio. I knew I was doing it wrong. Okay. A ratio compares two different units. Okay, and a rate is a type of ratio that compares two quantities measured in different units. So this one is miles and hours, things like that. Okay. A unit rate is when the second quantity in one unit is 1. Okay, the number 1. Okay, same thing, a proportion is used to compare two units and solve for a missing part. Okay, so same thing, same steps. We're still going to set up a proportion, cross multiply, and divide. Okay, so this one says a boat traveled 32 miles in 4 hours. So I'm going to set up my proportion. It was miles and hours. Okay, and it said 32 miles in 4 hours. At this rate, how many miles will the boat travel in 3 hours? Okay, so that's hours, so I'm going to put 3 there and then do that. We cross multiply 32 times 3. Okay, so let's do 32 times 3. 3 times 2 is 6, and 3 times 3 is 9. So that's 96. So then we're going to do 96 divided by 4. Okay, so 96 divided by 4. 4 goes into 9. Sorry, guys, that's a 9. 4 goes into 9 twice because 4 times 2 is 8. 9 minus 8 is 1. Bring down the 6. 4 goes into 16 4 times. 4 times 4 is 16, so I'm at 0. So my answer is 24. So it goes 24 miles in 3 hours. Okay, my unit rate of the boat would be how many miles does it go in 1 hour? So we're going to do 32 miles over 4 hours. So we're going to set up the same proportion, miles and hours. But this time, my unit rate is going to have 1 hour as the one. Okay, so 32 times 1 is 32. And then we divide by 4. So we're going to do 4 goes into 32. 4 goes into 32 8 times. So it goes 8 miles every hour. Okay, that's my unit rate. This unit rate is the same as our rate of change, guys. So unit rate and rate of change, or slope, or constant of proportionality. Okay. These are all the same thing because all I'm doing is dividing the two numbers together. Miles divided by hours. So 32 divided by 4. That's all I did. And that gives me, all of these are the same. Unit rate, my rate of change, my slope, my constant proportionality, they are all 8. Okay. Okay, a percent, now we're on to our percent. A percent shows a part for every 100. Okay, percents, sorry, that should be capitalized. Percents can be expressed as a decimal or as a fraction. Sorry, my pen is running out. As a fraction, that's an F, guys. It's a cursive F. Or as a fraction over 100. Okay, percent of change is used to find how much a quantity has increased or decreased. Okay, so when it asks for percent of change, we're looking for when it'll ask you how much, what was the percent increase? That's the percent of change. Okay, so for percents, we want to set up a proportion, cross multiply, and divide. So same thing, percents, we're going to do the same steps. For percent of change, it's a little bit different. We want to subtract the original price and the new price, or the original quantity and the new quantity, and then divide by that original price or the original quantity. It's mostly usually used in prices, like how much did the price, what was the percentage change for the sale and things like that. So you see this a lot in stores when you're using sales. Okay, so let's start with percents first. Russell has a collection of 1,200 pennies. So 1,200 pennies. Okay. Of these pennies, 25% are dated before 1980, 35% are dated from 1980 to 2000, and the rest are dated after 2000. How many pennies in Russell's collection are dated after 2000? Okay, so the first thing we need to do is find the missing percentage. What's the percent of pennies dated after 2000? So I'm going to take the 2% I do know and add them together. 25 plus 35, 3, 4, 5, 6. And then because percents are out of 100, we're going to subtract from 100, and I get 40. So there are 40% that are dated after 2000. Okay, and then we're going to set up our proportion. Okay, so we want the after 2000 here, after 2000, and then my total here on the bottom. So when you're working percents, total is always on the bottom, and then whatever you're looking for is on top. So percentages always over 100. I'm going to put the percentage is 40 right there over 100, and then I'm going to take the total number of pennies, 1,200 pennies, and put it on the total, and then I'm looking for that part, how many are dated after 2000. Let me this up for this. Okay, and then we cross multiply 1,200 times 40. Okay, that's 0, 0, 0, 0, and then 0, 0, 8, 4. So 48,000, and then we're going to divide by 100. So 100 goes into 48,000. Oops, that should be 100, sorry. 100 can't go into 4, 100 can't go into 48, but 100 can go into 480 4 times. That's 400. And then 100 can go into 800 8 times. That would be 800. And then I'm left with 0. And I can't forget that 0. There's still a spot right there, so I'm going to put the 0 there. So my answer is 480 pennies were dated after 2000. Okay? When you divide by hundreds, so if you look at this, when you divide by hundreds, I can just, they have zeros on the end. So I can take off 2 zeros here, and then I'm left with 1 there, which means I can take 2 zeros off here. So now it's 480 divided by 1, which means 480 is my answer. So when you're dividing by hundreds, you can just chop off those 2 end zeros, and that'll give you your answer as well. Okay? Okay, let's do one more example for percent of change, and then we're done for today. The price of a pair of pants was reduced from $32 to $24. By what percentage was the price of the pants reduced? Okay, so this is a percent of change thing because we're trying to find the percentage that it changed. Okay, so I'm going to do the original price minus the sales price, what it was reduced to. So we're going to do 32 minus 24. Borrow from that 3, give that a 2. And then 12 minus 4 is 8. Okay? And then we're going to divide by the original price. So we're going to do 8 divided by 32. Okay? And if you notice, this is a fraction. And that means I have to do top inside. So the 8 and the bottom on the outside. So I'm going to be given a decimal for this, okay? Because percents are decimals. So 32 goes into 80 twice. 32 times 2 is 64. Borrow, that's a 7. That's a 10. 10 minus 4 is 6. 7 minus 6 is 1, and 160. And then let's see how many times 32 can go into 160. Let's try 5. 5 times 2 is 10. 5 times 3 is 15. Plus 1 is 16. Oh, look at that. 25. 160, that's 0. Okay, so we're going to convert this decimal to a percent. Okay, remember to convert decimals to percent, we take the decimal and we move it over twice to the right, and that gives me my percentage. So my percent here is 25%. So it reduced by 25%. Okay, guys, that's all you're doing today. I'll give you an assignment to do tomorrow, Wednesday and Thursday, and then you'll take a little mini quiz on Friday over all of this stuff. Okay, so make sure you go through the notes, you understand it all, and if you have any questions, let me know. Thanks, guys. You have a great day. Bye.